Hi guys, welcome to this 4 LED IoT light home. We're using Blynk IoT, Arduino Uno R3 and an ESP-01 module. You can see in the video we have done a little simulation for a 4 light home. So bedroom light, living room light, bathroom light and kitchen light. Each color is represented, and you can use a web browser as well as the app on a phone. And we're also using Blynk 1.0.1 with Wi-Fi. So this is the Fritzing diagram. We've got 4 LEDs with a respective resistor for each LED, as well as the wire going from port 8 all the way to port 11. These are the digital ports. We also have digital pin 2 and 3. If you look from the Arduino Uno R3 board, we've got an orange wire on pin 3. That's for the TX, that's the transmit, and the green wire, which is on digital pin 2, is for the RX, for the receive. And the purpose of this is to communicate with the ESP-01 module for the Wi-Fi, the IoT and so forth. We also need to power this thing up with a 3.3 volt circuit. We cannot use anything higher than that. So that is connected via 3.3. We also need 2 of these red wires to power this thing up. And of course we need to plug in the negative wire also. So as per the Fritzing diagram, in order to build this Blynk IoT device, we're going to need all these components. We're also going to need to use a smartphone as well, which is right here, and you can use an iPhone or an Android. You've got to use the Blynk IoT app. I'll get into that just a little later, but let's just put that aside for now and focus on the device. So let's just look at the components that you need. So you're going to need 5 male to female jump wires. You're going to also need 6 male to male jump wires. Of course, you have your Arduino Uno R3 board. You're going to need a half breadboard. You're going to need 4 220 ohm resistors, 4 LED lights. You're going to need the ESP-01 module, and this thing here is quite important. This is the ESP8266 ESP-01 Wi-Fi module downloader, also known as the ESP-Link version 1.0. And we need this in order to adjust the settings for the ESP-01 module. Now, before we build the device, we need to configure this ESP-01. We want to make sure that the UART and the baud rate is correct. We want this to be set at 38,400 baud. By default, it's 115,200 baud. What we don't want to have is problems with the packet size. Say if we're using a phone or a browser to transmit signals, like something as simple as turning a light on and light off, and the packet sizes are so big it causes problems with the device and causes the thing to cut off. So we need to configure this to be 38,400 baud. And in order to get that done, we're going to use our ESP-Link 1.0. So how do we link this up together? How do we put this together? So what we do is we take this and we insert it like that. So you see these male pins are not being covered by this, and this part are facing that way. So we need to put this into a USB port of our computer with Arduino IDE. So let's do that. Right, once we've plugged the ESP link in with the ESP-01 module on the top, we're going to load up Arduino IDE. We're using 1.8.19 in this video. If you've done it correctly, you should be able to load the serial monitor, but just make sure that you've got the right port. So it should be, yep, we're connected to the right port. If you go to serial monitor, we're a 115,200 baud. If you type in AT, just make sure that the module is working, and it is. If you want to check the UART and the baud rate, it's AT+UART and then a question mark, and you can see it's 115,200 and with 8101, right? We want to change that to 38,400. So we're gonna punch in AT plus UART equals 38400, 8, 1, 0, 1 for the baud rate and the UART. Okay, and you'll notice that when we try to do that, remember we need to set this now to 38,400 baud, otherwise we can't read it. Just to make sure that it's working, AT is okay, AT+UART question mark, and now it's at 38,400 with 8101 respectively. Right, and once that's done, we can take out the ESP-01 ESP link, and we'll start building this device. Okay, let's start building the device. So we've got the Arduino board and the breadboard. Now let's just move this stuff aside. So first thing we're going to do is we're going to connect the Uno board with the breadboard. So we need to power up these rails. So let's start with the 3.3 volt. All right, make sure you get it into the right pin. Okay, and put that into the positive rail as shown. And similarly, you want to do the same thing with the negative, the black wire, into the ground. So let's put that in. Okay, good. So far so good. Now we need to let's connect the ESP-01 module. All right, so we're going to need the male to female, and the reason for that is because, right, you can see the pins. The reason why we have to use the male to female wires is because of the nature of the breadboard. I was about to say motherboard. The nature of the breadboard and this, you can't simply just jam it like that. It will not work. Right, it will not work because of the way that these channels go this way, and it will not work like that. So these pins all have to be separated and not connected with each other. So this is not friendly with this, so we have to use these wires. Okay, anyway, let's make a start. So we're going to connect the positive and the negative together. Sorry, that's the wrong wire. We should be using the male to female. So let's work on that. So, all right, so this is going to be, all right, let's just jam that in there. And we also want the black wire. We'll just put that there. Let's make sure you get it into the right rail. There are times where I have put these components into the wrong rail. Sometimes it just doesn't power up. It could be even worse. Sometimes it could be catastrophic, but okay. You also want to make sure that you want to align it. And I'm looking at the Fritzing diagram on my screen. You can't see it, but I can see it. You want to make sure you put the right wire to the right pin on the ESP-01. Right, so we're going to power this thing up, so we've got to plug the two 3.3 volt on the channel, the positive channel, right? And yeah, the module will just dangle just like that. It will dangle. It's okay. It's fine. As long as the wires don't fall off, then it should be fine. All right, now the RX and the TX. So remember, we want number 2, green wire and orange wire. You can use any colors you wish. I mean, I'm just using these colors because I'm so used to RX and TX being orange and green for all the projects that I've done on YouTube and school and so forth. But you are free to use your own colors. Okay, so there we go. Right, so it's all connected. So there should be 1, 2, there should be 3 on that side and 2 on the other side. So there should be 5 all connected. We do have some pins, another one for the reset and another one for the flash, if you want to flash this device and program it, but we don't need to do that for this device, for this simulation. All right, you notice how it just kind of dangles with the wires and it holds it in place, and it should be fine. Now, these wires we need to connect the LEDs. Now also, we have the resistors. They're quite long, so if you have a pair of scissors handy, you could trim the resistors. I think I've done this on a couple of other videos. You can trim the resistors so they are not too long. So if you happen to have them like this, just trim them all at once and trim them. We don't want to have these resistors sticking out. We want it to be flat on the breadboard. At the same time, we want to be able to make sure that it goes into the breadboard, so we don't want to make the legs too short. Right, now we've got 4 small resistors. Okay, bend them right, L shape or a 90-degree angle. And right, we're gonna go red, orange, yellow, red, yellow. I'm thinking of the colors of the rainbow, so it should be red, yellow, green, blue, no orange, sorry. We don't have an orange LED in our possession. Okay, now we want the we want the anode leg to be left, and we want the cathode leg, that's the short leg, to be facing right. So let's do that. So let's put that there. So that's the red one, and I don't think it needs to be so far to the left. We could sort of smack it in the middle. Let's just try. Okay, it should be fine. So red, yellow. Again, make sure that the anode long leg is on the left and the cathode short leg is on the right. Okay, but now they're all in. So now the next thing to do is we want to get these resistors in there. So I'm going to turn this around so you can see it better. We want to plug the resistor into the negative rail and plug the anode, the long legs, into the digital pins. So let's get that sorted. Okay, so we should have, hold on, so just remember we flipped it around, so now the short leg is on the left side. Reason why I'm going for 4 LEDs is because you can have 4 bedrooms in your IoT smart home. Okay, so let's get that in there. Right, I think that's it. Now we want to get these wires connected now, because these are short wires. You can use long wires, but I don't want long wires dangling all over the place. So what I do is I have the digital pins here, and I have access to the anode here, so I can just use a short wire, no problem. So we use the red wire to connect the red long leg, and that should be on pin 8. So luckily we have the actual Arduino board. This is the genuine board, mind you, so it has all the numbers on the side. It's really convenient. So we just push the number 8, just like that. So number 8 and number 9, just connect all the colors. And number 10 and number 11. You can put them in any ports you want, but you're going to have to remember, or at least you're going to have to know which ports you put them into, because that's going to be important when we start programming on the Blynk cloud, and we'll get to that in just a moment. Okay, now that looks like, and that's what we get. All right, so we've got ourselves the, we've got the lights, got the Arduino board, and we also have the ESP-01 module just like that. So there we go. Brilliant. Now we can also grab ourselves the USB wire. So one end here, and let's plug in the other end. Okay, let's plug that in. So 3, 2, 1, and yep, lights up, no problem. Okay, at least we know it's powered and it's going to work. We've got to get the program in. So let's move on to the next part. So for this part, we're going to set up the Blynk IoT app we're also going to use blynk.cloud on computer. So first you need to go on your phone, whether iPhone or Android, you need to download Blynk IoT, right? And once you've downloaded that, you can open up the app and you'll get this. We're going to use a computer to sign up, so let's switch to computer. Now on Google Chrome, a web browser, let's go to blynk.cloud and we're going to sign up for a brand new account for blynk.cloud. Right, so first you need to sign up and put in your email address, and you want to press the box for I agree and hit the sign up button as shown. Right, you'll get an email and you need to verify your account, and just go to your email and verify. And once you've done that, you should be able to, well, you need to set yourself a password. So we're going to do that now. So set yourself a password. And once you've done that, you should be able to continue. Yep, put your first name. All right, there we go. We now have an account. So if we go back to the computer, click on the back to login. So put in the email address that you used to register with, and this is going to be your username from now on. And put in the password that you just created on your phone. And press login. And there we go. Now, before we start creating and uploading code to our Blynk IoT device, we have to go onto Blynk Cloud, blynk.cloud, and create a template for a device to prepare that so that we can upload the right keys and the right tokens and so forth into the board. So just bear with me for a moment and I'll show you how it goes, and it will all make sense. Okay, so now we're in Blynk Cloud. So what we need to do first is go to templates on the left hand side, and we're going to create a new template. So click on that. Now give your template a name. So I'm going to call it IoT Home Lights. You can call it anything you like, just something catchy, something relevant. Okay. Now for hardware, we are using Arduino. There's lots of different hardware you can use, but we are using Arduino. The connection type is Wi-Fi. You can put a description, but you don't need to, and then hit the done button. Now, you'll notice that there is a template ID and a device name. You're going to need that for your code later for Arduino IDE. We'll get to that later. We're not quite done yet. Now, something else you need to do is you need to specify which pins do what, which pins are input devices and which pins are output devices. So what we have to do is go to Datastreams. Okay, we're in the template IoT Home Lights, mind you. Go to Datastreams and press New Data Stream. Now, we're going to, if you remember the Fritzing diagram, we have 4 LEDs and we are going to have red, yellow, green, blue for digital pin 8, 9, 10, 11 respectively. So what we do, go to New Data Stream, go to Digital, and we're going to call this, let's call it LED underscore pin 8. And you can choose a color if you want to, you don't have to, it's usually automatic. And remember to assign that to the right pin. It's an LED, so it's an output. So click create, okay, that's that. Now you want to do the same for the others. Now you could just go to new data stream, go to digital, and do the same thing. Now I could call these like bedroom, bathroom, living room, kitchen, whatever, but I'm just going to call it by the pin number. Okay, now this one I'm going to make yellow. So, and then this will be pin 9, and you just keep going. You can't use pin 8 because it's already been used for the red light. Okay. Right, you can also copy them as well, I believe. So if you can duplicate them. So you can say copy 9 and put that into 10 instead of pressing new data stream all the time. It's entirely up to you how you do it. So, and this will be green. Okay, and then do another one, and this will be pin 11. Just make sure you choose the right pin. And yep, and that should be blue. So there we go. Right, and don't forget to save. Now, we want to make a user interface for Blynk.cloud when we use it on a web browser. So this is Google Chrome. So if we're going to use a web browser, we need to have a user interface. So we go to Web Dashboard. We'll do the mobile one on phone later. Now, for the web dashboard, what we have to do is press Edit. We need to create the buttons. So we want to be able to have 4 buttons. Each button is going to turn on one of the lights. Okay, so we need 4 switches. So lay out the buttons on the screen. You can lay them any way you like. There's all these other ones as well that you can add, but we're going to keep it simple. We're just going to be turning lights on. Right, and you can resize them as well if you so choose. So we need to start labeling them, and we need to start referencing the right pin numbers as well. All right, so we start with this one. Go to Settings, and go to the data stream. So we want pin 8. Okay, and pin 8 could be the bathroom light. And you could have the on-off labels. And this is what it would look like, right? And you can test the button like that. So you can either have the name on or have it off. I just like to have it like this. Again, it's entirely up to you how you do it. Right, so that's a bathroom light. And this one could be the, I don't know, living room light. Make sure you choose the right data stream, so each one is going to be different. So do this one, bathroom light, living room light. Okay, just stretch that out slightly. Bathroom light, living room light, and then this will be kitchen light maybe. So this is a bit like a smart home, an IoT home, where you can turn lights on at a home using a phone or using a web browser that's connected to the cloud with Wi-Fi. Okay, now for this one, we'll call it the bathroom light. Oh wait, hold on, did we do bathroom? Hang on. Oh, we did, sorry. That will be the bedroom light. Sorry, it should be bedroom. Okay, let's do that. So that's the bedroom light. Okay, if you don't like the name, just go in and just rename it. No problem. Right, so there we go. Now we save it, and this is how it would look on the device, and we can just flip the switches. We still have to upload some code. We still have to create some code for our Arduino device, so just bear with me. Right, okay, there's our template, and if we go back to templates, you'll get this. Now, let's go to the phone. So, on the Blynk app on your phone, this is the iPhone version, go to the developer mode, so it's the option at the bottom, and you'll see the template that says IoT Home Lights. Now, you will recall that we created an interface, but that was only for the web version, the Blynk Cloud version. The one from Blynk.cloud on a web browser does not carry over to the phone. The phone version and the web browser version are 2 separate interfaces, so we have to make a standalone version on the phone. So, to do that, in developer mode, we press IoT Home Lights, okay, and you'll get something that looks like this. Now, on the top right corner, you'll see a plus button. Hit that button, and you'll see under controllers, it says button. So press that, and now you've got one button, right? And press that button, and now we want to give it a name. So if you remember what we called it, so I think the first button was, let me see. The first button was bathroom light, wasn't it? Yes. Okay. And remember, bathroom light we set to number 8. You can change the color if need be, right? It's, again, as I've said before, it's entirely up to you. So bathroom light is 8. Now, you want to make sure that you use switch, because I think if you use push, let me show you what happens if you have a push button. Right, if you have a push button, oh, hang on. If you have a push button, you have to hold, I can't show you now because the device is not online. If you use a push button, you have to hold the button down and you turn it off by letting go, which can be quite repetitive because you've got to keep your finger on it. So we use switch. By using switch, you just push the button and it's already on. You turn it off by just hitting the button again. And so every button that we put on this interface should be switch. All right, you'll see in a moment later what I'm talking about. All right, so now let's keep going. I think right, hang on, sorry, let's go back. All right, let's hit the let's just do what we did for all the other buttons. So this one will be living room light, and this will be pin 9 on the board, so that's a switch, and this will be the yellow button, so we've got the colors conveniently at the bottom, and let's, yep, that's good. Now we want another button, and this is the kitchen light, and this will be pin 10. Oh, excuse me, did that wrong. And switch, and that will be digital pin 10, and that's the green button. And last but not least, we have the bedroom light. So bedroom light, and that will be pin 11, and that's blue. Right, make sure that's a switch. Okay. Right, we want to organize these buttons a little better. So let's put the kitchen light and the bedroom light at the bottom. So you need to hold the button down and then you can just drag it to wherever you want it to go. Now I want this button to go on the right. If you hold the button down, you can stretch it out like that. Any way you see fit. Right, so once you've got them in the right size and the right position, then you are good to go. After this, we're going to create some code and we need to upload it to our Arduino board, the Blynk IoT Arduino device with ESP-01 for Wi-Fi. All right, that'll do. Okay, so there we go. Now the next thing we're going to do is create some code and upload it to the Arduino Uno board. Now, in order for us to do that, we have to use Arduino IDE. Again, we are using version 1.8.19 at this moment in time. So we also need to use a code generator, and the easy way to do that is we're going to use something called the Blynk example browser. Now let me show you what that looks like. So it's examples actually .blynk.cc, just like that. And this will help to generate the code for the Arduino Uno board. So first thing we need to do is choose Arduino Uno as the main board, and we're going to use the Arduino ESP8266 Wi-Fi shield, which is the equivalent of the ESP-01 module. Right, and you'll notice when we use that particular drop-down box, it will generate the respective code. Now, over here you will see it says template ID, device name, and auth token. And what this does is this will help us to connect our Arduino Uno board via Wi-Fi to blynk.cloud. Right? The problem is we don't have all these details yet because we have to go to blynk.cloud and sort it out. So that's what we're going to do now. So we'll just put that aside for the time being, the Arduino IDE, or we could just minimize it. All right, we'll get back to that later. So we're going to open up another browser and we're going to go to blynk.cloud. Right, and yep, we're signed in. We should be signed in already. If you're not sure, yep, we are signed in. Okay, good. Now, in order for us to set up a new device, we have to go to search, and down at the bottom, there's a button that says new device. Right now, we have no devices. We're going to create a device from the template that we just made before. So this was the template, okay? If you remember from all the LEDs, and we've got the web dashboard, And we also have the mobile dashboard on the phone. So go back to search and hit new device. We're going to use the template that we created before, and that's the IoT home lights. And we'll just call it the same name. It doesn't matter. IoT home lights it is. Okay. Now, if you see this, it says this is the template ID, the device name, and the auth token, and this is going to connect the Blynk cloud with our device. But in order for that to happen, we need to put this code into the board. So we need to copy this, and it will copy it to the clipboard, right? Well, actually, sorry. We're supposed to copy and paste each bit line by line, although what we could do instead, we just click copy example. It will copy all of this code to the clipboard. And now let's get back to Arduino IDE. And what we do is we simply just delete all this and just Command V and just paste all the code onto the screen, into Arduino IDE, into the sketch. Now, we can just go back to the console, the Blynk.cloud console, and just copy all of this. And inside the code, you will see it actually says template ID, device name, and auth token. So all we have to do is just highlight this. By the way, I might just make this a bit bigger, a smidge bigger. Okay, we just highlight that and Command V, and it will paste all of that accordingly. Right, now, around here, where it says SSID and password, you want to put your Wi-Fi credentials in here. So, in order for that, you've got to put in your Wi-Fi SSID, right, and then put in your password. Now, down here, you have to specify, are you using a mega board, Leonardo board, or a micro board? And if you are, you're going to use hardware serial. But since we are not using that, we're going to take it out. So put the double slash to rem this out. Since we are using the Arduino Uno, similarly, we have the Nano as well, but we're using the Uno. You have to take out the slashes because we need to include this in the sketch, in the code. All right. The ESP8266 baud rate is 38,400. We set that already with the ESP link. Oh, excuse me. Right, and let's see. Yep, the serial debug console will be at 115,200. That's not a problem. Now, for this part here, this is what is needed to connect the Arduino IDE, the Arduino Uno board to the Blynk cloud. Now, I would like to try and make sure that we do connect to Blynk Cloud and not the old Blynk server. So in order for that to happen, if you rem this out, and we're going to use this line here, so it always guarantees to connect to the new system, Blynk.cloud. Because there's actually two versions of Blynk. There's the legacy version, and then there's Blynk Cloud for Blynk IoT. So there we go, that's what we want. And that code is pretty much, it's ready to go. So we can, it should be saved automatically. And then we want to verify that. Okay. Now, you might notice that it's missing a library. So what we have to do is we need to install the Blynk library into Arduino. Let's go to Google and let's search for the library. So search for Blynk library. It's on GitHub, so the first one. And you'll see this. Scroll down to the very bottom. Or no, go to the Arduino library. Sorry, it's right here. And yep, version 1.0.1, that's what we've been using. And down at the bottom, you'll see Blynk release v1.0.1. Just download that and it will download accordingly and go into your downloads folder. So it should be there, and just double click and you've got the files right there. So in that folder, you'll see two subfolders, one called libraries and one called tools. We need to put that into our Arduino folder in the documents. So let's open up another tab. Let's take that out, okay? So we can have them side by side. And what we'll do, Okay, so this is the documents folder, and we go to Arduino. If you're on Windows, you'll have something similar in your own documents folder. Go to libraries. Okay, and now in libraries, you want to copy all of this. Just drag and drop in there. And copy the tools folder in there. Okay, just like that. We want to verify this code. And it says done compiling. I mean, that means the code is all ready. Everything has been validated. And yep, that should be fine. So we want to make sure now that we are connected. Okay, you want to go to Tools, go to the board, make sure it's Arduino Uno, make sure you've got the right port, everything should be up and running, and simply just upload. Right, and that should be that. Now, go to the serial monitor, and let's see if that thing connects. So you've just got to wait. You might have to wait a little bit. Right, it seems to be doing its thing. Right, it says connected to Wi-Fi. Right, it's assigned an IP address for the ESP-01. And once it says ready, then it's ready. Now, let's give this a try. Let's test it and see if it works. So let's see if we can get this working. So we've got our Blynk IoT device right there with Arduino Uno and the ESP-01 and the 4 LEDs for bedrooms and bathrooms, living room and kitchen. We also have, just to make sure that everything is working, we have the serial monitor as part of Arduino IDE. We are connected to the Wi-Fi. We have the IP address also on there. Okay, so that's going to be fine. And on the right-hand side, the Blynk Cloud, right, with all of the buttons and everything on the web dashboard. And we also have the phone. Oh, hang on, we have the phone as well, which is right here. And we've got the Blynk IoT app, IoT home lights right there. Let's hit that. Now let's give this a try. So we've got the bathroom light. Yep, it turns on. And notice the bathroom light turns on the web dashboard as well. So it pushes accordingly. So it's all real time. Kitchen light, living room light, and bedroom light. And you can have combinations just like that. And if you don't want to use the phone, you can simply just put it aside or turn it off or whatever you choose and just hit these buttons instead. If you have a touchscreen monitor, even better, or you can just use a mouse. Right, so I'm using a mouse right now to adjust the buttons, the switches. So let's say I'm in the bathroom and I want to turn the bathroom light on. Yep, someone might be using the bedroom, so turn that light on and you get the idea. Now, I did say earlier I would show you the difference between a push button and a switch. So let me show you on the phone. Now, right now, these are all switches because if I push them, the lights will stay on. Okay, they will stay on. However, if I press this, let's say I want the bedroom light. Well, hang on, tell you what, before that, let's turn them off first. If I hit the wrench, and what I'm going to do is I'm going to press the bedroom light. Right now it's on switch. If I change that to push, and if I get out, so again, right, so bathroom, living room, and kitchen lights will stay on. But if I press the bedroom light, it turns on for a fraction of a second and it goes off. So if I hold it down, it will stay on. If I let go, it will stay off. Quite repetitive, hence the reason why it's better at a home to use a switch. And that way, if you press it, it stays on. Yep, pretty common, okay? And of course, this being an IoT device, this being a smart home device, you don't actually need to have this connected to a computer. You can hook up a battery. You could take out the USB wire and hook up a battery and it will work. Just as long as you're connected to Wi-Fi, to the Blynk Cloud. If everything's connected to the Blynk Cloud, it shouldn't be a problem. So there we go. It works. And thank you so much for watching. I wish you all the best of luck with this project. If you have any problems, any issues and so forth, please feel free to ask. So thank you so much for watching, and we'll see you soon. Goodbye. Thank you.